Newton's third law of motion. Objective: to understand Newton's third law of motion. From the first two laws, we have seen that the acceleration of a body depends on the force acting on it. We have also studied the relation between the force applied and the acceleration produced. Consider a ball, initially at rest, being rolled down a floor. It hits a wall and immediately starts moving in the opposite direction. Why does this happen? Newton's third law of motion states that if a body A exerts a force on body B, then body B exerts an equal but opposite force on body A. Accordingly, when the ball hits the wall, it exerts a force, say the action force on the wall, but simultaneously the wall exerts another force, say the reaction force on the ball. The reaction force has the same magnitude as that of the action force, but both the forces act in opposite directions. We have already studied in the second law that acceleration produced in any body is inversely proportional to its mass. Hence, here, the same amount of force, say F, is acting on the ball and the wall. The mass of the ball is much less as compared to that of the wall. The acceleration produced by the reaction force in the ball is appreciable, and the ball starts moving in the backward direction. But the mass of the wall is much larger, so the action force produces negligible acceleration in the wall. Hence, the wall does not move. When we walk on the floor, our feet exert a force on the floor. But due to the extremely large mass, the floor does not experience a displacement. Simultaneously, the floor exerts a reaction force on our feet, and we move forward. Similarly, when a gun is fired, an action force is exerted on the bullet, and the bullet moves forward. Likewise, the bullet exerts a reaction force on the gun due to which the gun recoils. But the gun has greater mass than the bullet, hence the acceleration produced in the gun is less. A diver applies a force downwards on the springboard before jumping into the swimming pool. This downward force is the action force. The springboard exerts a reaction force on the diver, and as a result, the diver moves upwards. This helps the diver to take the jump from a greater height. Similarly, when a boxer in a practice session punches the punching bag with a great force, he applies an action force on the bag in the forward direction. An equal force in the backward direction, called the reaction force, is exerted by the bag, which may hit the boxer. Thus, we have understood Newton's third law of motion, which can be stated as every action has an equal and opposite reaction. Summary: Newton's third law of motion states that every action has an equal and opposite reaction. Boxer practicing on a punch bag and gun recoil are some of the few examples of Newton's third law of motion.